All right, GRE 502 Level 4 is about writing equations and expressions. And before we move on, we need to know the difference between an equation and an expression. An equation is something that has an equal sign in it. So an example of an equation would be like c equals 2x minus 1. And this would be the equation. The expression does not have an equal sign, so that would be 2x minus 1 would be an expression whereas c equals 2x minus 1 would be an equation. That's just an aside. So let's move on to some problems. A bicycle manufacturer's operating costs are $15,000 per year and $24.25 per bicycle. Now, whenever you see this word, it's important, per bicycle. Write an equation, so that's going to have an equal sign, to represent the manufacturer's annual costs, where C is cost and B represents the number of bicycles. So when it says to represent the manufacturer's annual costs, that means that C is going to be on one side of the equal sign and the rest of the equation is going to be on the other side of the equal sign. Now we need to think about the components of the cost. Up here it tells us that we've got this $15,000 per year. So within 1 year, annual means yearly, within 1 year this happens once. Okay? And then we see $24.25 per bicycle. We know that B has to be in our equation, and that represents number of bicycles. Whenever you see the word per next to whatever the variable is, that's going to mean multiplication. So it's $24.25 for each bicycle. So if you think about how this will change as you increase bicycles, it'll be double when you have 2 bicycles, triple when you have 3 bicycles. So that $24.25 is dependent upon the number of bicycles that you buy. And then the $15,000 happens one time per year. So for the annual cost, you just have to add this on once. And that would be your equation. That's it for this problem. This would be your equation. That's probably the simplest level 4 that you'll see. Let's move on to something a little more difficult. Jane, Kim, and Sam are riding across country. Kim rides 3 times more miles than Jane. It's probably important. And Sam rides 4 fewer miles than Kim. Write an expression, so no equals sign, to represent their total mileage where J is Jane's mileage. So our expression has to only have one variable in it, and that's J. So we need to make everything else in terms of J. We've got Kim, we have Sam, and we have Jane. We know that Jane's mileage is going to be just J, because J is Jane's mileage. Then we need to look back at the problem. It says that Kim rides 3 times more miles than Jane. So 3 times Jane's mileage is Kim's mileage. Okay? And then it says that Sam rides 4 fewer miles than Kim. So Kim's mileage minus 4 gives you Sam's mileage. And we know from right here, up here, that 3J is Kim's mileage. So if we want to write Sam's mileage in terms of Jane's, in terms of that J, we're just going to do 3J minus 4. All right, and if we're looking for total mileage, that means we have to add. So 3J, do this over here, Kim's mileage plus Sam's mileage plus Jane's mileage. Now we need to combine like terms. 3J and 3J is 6J another j, that makes 7 minus 4. So what this means is their total mileage is 7 times Jane's mileage and then 4 less than that number. So 4 less than 7 times Jane's mileage. And that would be your answer here. Our last question is even a little bit more difficult. So let's read through it first. The football team is going to a game D miles away. They begin driving at an average rate of 55 miles per hour. They stop for lunch for 30 minutes and then continue the trip at the same rate. So the whole trip is traveled at a rate of 55 miles per hour. And then we have a break in there of 30 minutes. We want to write an expression, so one without an equal sign, to represent their total time in hours in terms of D miles. So right away we have a little bit of a problem here. It's pretty difficult to think about how D is related to rate if you don't know distance equals rate times time. This is a very important equation. It'll pop up all over the place in physics, in real life problems, also on the ACT this would pop up. Distance equals rate times time. And here's why we learned how to manipulate equations. If we're going to be dealing a lot with, we want this to be in terms of D, and we're given R, and we're trying to find time. So in order to make this more useful, we want to solve for time. So divide by R on both sides, and we get our time is equal to distance divided by rate. Okay. We know that the total time is going to be that amount that's spent traveling plus the amount that we spent for lunch. So the amount that's spent traveling is going to be, well, D miles over our rate, which is 55. That's the amount spent traveling without lunch break. So D over 55. And that is in hours. Okay, and then we want to add on the amount of time that we spent for lunch. You don't want to add 30 here because our original time is in hours and it asks us for our total time to also be in hours. So you need to convert 30 minutes to hours, and it ends up being half an hour, so 0.5. So our final answer here is D over 55 plus 0.5. That's it. You could change this into a decimal if you really want to. I don't know what that is right off the top of my head, but you could do that. And then you have this 0.5 as a loose number because you only stop for lunch one time, and the amount of time it spends to actually drive depends on the distance, and that's why we've got this part over here as well. Alright, I expect this to be the hardest part about this skill, so if you have any questions on this, feel free to ask, but if you're having trouble with level 1 and 2, please focus on those first.